Hello, this is Dr. Hanaa Assil. Today we're doing questions and answers on groups 1 and 2 elements and their reactions. This is for IAS Edexcel chemistry. And the first question that we have is, a student made the following statements about trends going down group 2. Which statement is correct? Again, the main information in this chapter is about the trend going down group 2, the thermal stability and solubility of the different compounds. And you have to remember, for example, this first option says the thermal stability of the nitrates decreases going down the group. Well, let us see. Nitrates are large atomic groups. You have to keep in mind, if I have a large atomic group with a small atom, it is more likely to be polarized and therefore more easily breaks down or more easily dissolves. But if I have a big atomic group with a big atom, and that's at the bottom of the group, these are usually very strongly attached to each other. The large group in group 2 ions will not polarize the atomic group very much, so these two will not break down easily and they will not dissolve easily. So if you're looking at nitrates, the magnesium nitrate is more easily broken down, and that means that it is less thermally stable. Remember, the thermal stability means if something is thermally stable, that means it does not break down by heat. Well, magnesium nitrate is more likely to break down by heat than barium nitrate, and that means as I go down, the thermal stability of the nitrates actually increases, not decreases. The same for the carbonates. As we go down the group, the thermal stability of the carbonates increases, and that means barium carbonate is less likely to break down by heating. Now, if we're talking about the hydroxide is a small atomic group. Now, small with small will be very difficult to break down. So, magnesium is a small atom at the top of the group. With the hydroxide, it is very strongly attached. It is less likely to dissolve. It is less likely to break down by heat. While going down the group, the barium is a large atom, so large with small will easily break down, will easily dissolve. So when we're talking about hydroxides, the solubility of the hydroxides going down the group, it does increase. The sulfates are just like nitrates. So remember, nitrates, sulfates, carbonates are all large atomic groups. Going down the group, it becomes more thermally stable, less solid. Hydroxides, it's the opposite. Hydroxide is a small atomic group, so going down the group, it is more likely to break up, more likely to dissolve, less thermally stable. Okay. Compound X gives a red flame test color and a white precipitate on addition of dilute hydrochloric acid followed by barium chloride. Okay, first of all, he's talking about the flame test. Which ones give me a red flame? You have to remember lithium and strontium are regarded as red. So my answer here could either be B or D. But then he says it has to give a white precipitate with barium chloride. Remember that acidified barium chloride, if it gives me a white precipitate, that means I have a sulfate, not anything else. So that means that what we have here is lithium sulfate. The next question says, which process explains the flame color? You have to be able to explain. Why do group 1 and 2 elements give specific colors when heated? You have to remember that when one of these ions is heated, the heat is absorbed and used to transport an electron to a higher energy level in which it is an excited state. Now, the electron does not like to be in this higher energy level. It needs to go down. When it goes down, it gives out the same amount of energy that it absorbed. If this energy is within the visible region, then I will see a specific color. So actually, why do we see flame colors for these elements? It is because the emission of visible light energy as electrons return to lower energy levels. This is in the visible region. A solution of a metal ion produced a white precipitate with barium chloride. Remember that if I add the barium chloride without acid, then the white precipitate that forms could be due to sulfate or to carbonate. It is due to sulfate only if it is acidified barium chloride and I still get a white precipitate. But here he's saying he got a white precipitate with barium chloride. That means it could be a sulfate or a carbonate. And then he says the mixture fizzed when dilute nitric acid was added. Remember that what gives a gas when adding acid to it is a carbonate. So that means that I must have sodium carbonate. That is the only carbonate in that list of choices. Okay, the less soluble or the least soluble hydroxide and the least soluble sulfate of barium and magnesium. Again, we said when we talk about hydroxide, which one is least soluble? The one that has a small atomic group. Because hydroxide is small, and we said small with small is less soluble, so the magnesium hydroxide is less soluble. Barium hydroxide is more soluble. We said big with small is more likely to dissolve, more likely to break down on heat. So with respect to hydroxides, the least soluble is the magnesium hydroxide. That is the one that will not easily dissolve. Now with sulfates, which one is least soluble? The big with big. Barium sulfate is least soluble because the other one where the magnesium with a small atom, then it can polarize the negatively charged atomic group. So least soluble, magnesium hydroxide and barium sulfate. The reaction which results in effervescence. Which of these will give effervescence? What happens if I put calcium in water? Remember, when we put calcium in water, it reacts to give hydrogen gas. So this is actually the one that will give effervescence. Strontium and chlorine, well, that gives strontium chloride. Strontium chloride is not a gas. Magnesium oxide and water. Magnesium oxide and water will just give magnesium hydroxide, which is still a solution. Barium hydroxide and nitric acid, what would that give? Barium nitrate and water, no gases. So the only one that will give a gas that could result in effervescence is calcium and water. The metal salt, which gives a red color in a flame test. Again, which one gives a red color? We said a red color is either lithium or strontium. So among these choices, the only one I have is the lithium compound. What is the trend in thermal stability of the carbonates and nitrates as group 2 is descended? Again, we said carbonates and nitrates are big atomic groups. So the one that is more thermally stable is the one with the big atoms. So the barium carbonate is more thermally stable, and as we go down, the thermal stability increases. The same for nitrates. Nitrates are big atomic groups, so nitrates with a big atom or ion from group 2 is more thermally stable. So in both cases, as we go down the group, the thermal stability increases. Are we paying attention? So big with big is stable. Small with small is stable. But when I have a small ion with a big atomic group, that is more likely to break down, more likely to dissolve. Okay, which pair of compounds have the more soluble hydroxide and the more soluble sulfate? Again, for the hydroxide, which one is more soluble? The one down. For the sulfate, which one is more soluble? The one up. So in this case, it is strontium hydroxide and magnesium sulfate. Separate samples of lithium carbonate and magnesium carbonate were heated. The lime water went cloudy. For which of them? Of course, both carbonates will break down and they will give carbon dioxide gas. In a test with lime water, the cloudiness is due to the formation of a precipitate of what? When we pass carbon dioxide through lime water, you should know that lime water is actually calcium hydroxide. Now, if I pass carbon dioxide through it, it will form calcium carbonate, and that is the substance that will be a white precipitate, which would cause the cloudiness, or when we say the lime water turns milky. Anhydrous calcium nitrate. Okay, calcium nitrate, when it decomposes on heating, what does that give you? You should realize that nitrates of group 2, when they break down, they give what? They give the oxide plus nitrogen dioxide gas plus oxygen. Well, the oxide is a white solid. The nitrogen dioxide gas is a reddish brown gas, and oxygen is a gas that lights a glowing splint. So which of these, the action of heat produces a white solid and what? It produces a white solid and a brown gas and a gas that relights a glowing splint. Decomposition occurs quite easily because of what? Why is it that these decompose easily? Remember, they decompose easily because of the polarization. And which one is being polarized? It is the nitrate ion that is being polarized. The negative ion is polarized by the positive ion because the positive ion has a large charge density. Give the formula of two metal carbonates that could be used to produce a bright red color. So I have red color. Now, which one gives me a red color? Lithium and strontium. So he wants the formula. So that is lithium carbonate. Lithium is in group 1. Strontium carbonate. Strontium is in group 2. Explain by reference to electronic transitions how the metal ions produce the colors. Again, how do they produce the colors? We said the heat from the fireworks, he's talking about fireworks in this question, excites electrons to a higher energy level. When these electrons return to the ground state, they release energy in the visible region, and that is why we see a color. This is how you explain how we see any colors in the flame. Now he's saying suggest a metal which may be used to produce a white color. We said which one gives white? The magnesium. We said magnesium burns with a bright flame or white flame. And the name of the compound that is formed when magnesium burns is magnesium oxide. This question says magnesium reacts slowly with cold water but rapidly when heated in steam. Remember, when a compound reacts with cold water, it forms the hydroxide. So this will form magnesium hydroxide. Now, if we're reacting it with steam, what is formed is the oxide. Plus what? Plus hydrogen. So the other product is hydrogen. Then he's saying calcium chloride can be formed in two ways. By reacting calcium with different reagents. So he wants you to react calcium with something to give calcium chloride. Write the equation with state symbols. So what could calcium react with to form calcium chloride? Either it reacts with chlorine gas, that would form calcium chloride, and remember calcium chloride in itself is a solid. Or what else? We can react it with HCl. In that case, it will give calcium chloride plus hydrogen, and all of this is in aqueous solution. So the calcium chloride here is an aqueous substance. Thermal decomposition of group 2 carbonates can be investigated using the apparatus shown. State why it is necessary to remove the delivery tube from the lime water as soon as heating is stopped. Now, this was one of the experimental techniques that if I'm heating something that has a delivery tube going into a solution, I should remove the delivery tube before stopping the heat. This is to prevent back suction of water into the hot tube, which would break it. Then he says, give the formula of the chemical compound in lime water that reacts with carbon dioxide. Again, you have to remember that lime water is actually calcium hydroxide. Identify the chemical compound that is responsible for the cloudiness of the lime water. Again, when we pass carbon dioxide through slaked lime or lime water, this forms calcium carbonate, which is not soluble in water, so it forms a cloudiness or it causes the reaction to be milky. Magnesium carbonate took 2 minutes of heating to produce enough carbon dioxide to make a sample of lime water go cloudy. State and explain the trend in the time, so here he's talking about time, taken for decomposition as group 2 is descended. Again, he's talking about what? Carbonates. We said as carbonate is a big atom, as we go down the group, is it more thermally stable or less thermally stable? We said big with big. As we go down the group, it's big with big, then it is more thermally stable, less easy to break down. So it will take what time? More or less? It will take more time. So time taken increases because as we go down, it becomes more thermally stable. And we said this is because going down the group, the radius of the metal ion increases, more shells, less charge density, so the polarizing power of the metal decreases, of the metal ion. There is less distortion of the electron cloud of carbonate ion, so the weakening of the CO bond in the carbonate ion decreases, so it is less easy or it's more difficult to break off and form the oxide and carbon dioxide, for example. Explain why a saturated solution of barium hydroxide is more alkaline than a saturated solution of magnesium hydroxide. Again, this has to do with the ease of its breaking off. So, barium hydroxide, we said big metal ion with small atomic group, this is easy to break up. So the barium hydroxide is more soluble and magnesium hydroxide, so it will form more hydroxide ions than the magnesium hydroxide. The color seen in a flame test is characteristic of the metal ion. For example, barium ions give a green color, while calcium ions give a yellow-red color. Explain, with reference to the electronic transitions involved, how these flame colors are formed and why the flame colors are different. Remember, we said, first of all, how are they formed? It is because when the electron absorbs the energy, it moves to a higher energy level, and then coming down to its original energy level, it gives out that amount of energy in the form of light. Now, why do they have different colors? This is because different metals have gaps of different sizes, so they absorb different amount of energies to go up, and then when they go down again, they emit different wavelengths, and this gives different colors. Which is the equation for reaction when steam passes over strongly heated magnesium? Again, we said if we pass steam over strongly heated magnesium, well, steam with a metal forms the oxide plus hydrogen. And remember that magnesium oxide, of course, is solid. Water in this case is steam because this is at very high temperature. So the water, the state symbol for water in this case is gas. What happens to the solubilities of hydroxides and sulfates as we go down group 2? Again, hydroxides at the top are very stable. As we go down, the solubility increases. Now, the sulfates, as we go up, this becomes more and more soluble because we said when we have a big one with a small one, that will dissolve easily. So actually going down the group, the solubility of the sulfates will decrease, but for the hydroxides, it will increase. Chlorides of magnesium and calcium can be distinguished from each other by carrying out a flame test. Describe what you would see if we have magnesium. Well, magnesium, remember we said magnesium gives no color. And if he says why it gives no color, this is because the light emitted is not in the visible region. Calcium, on the other hand, will give a brick red color. State why the observations are different. We said the energy levels are different. Magnesium emits energy outside the visible region, while calcium emits energy in the red region of the spectrum. Which of these metal salts give a lilac color? Which one gives a lilac color during a flame test? Well, you should remember it is potassium that gives a lilac color. Lime water is an aqueous solution of calcium hydroxide. Lime water is used in the laboratory as a test of carbon dioxide. What do you think would be the pH of lime water? Well, calcium hydroxide is obviously a strong base, so you would get a pH of about 12. Write an equation including state symbols for the reaction that takes place when lime water is used to confirm the presence of carbon dioxide. Remember, the lime water is calcium hydroxide. It reacts with carbon dioxide, which is a gas. This gives calcium carbonate, which is a solid, and that is what causes the cloudiness of lime water. Here he's saying slaked lime can be prepared from calcium carbonate in 2 stages. Outline how this preparation will be carried out in the laboratory. Include an equation for each stage. State symbols are not required. You do not need to include any details of apparatus, but you should mention any essential conditions. Okay, what are we trying to prepare again? We're trying to prepare calcium hydroxide from calcium carbonate. You remember how to do that? We said the calcium carbonate, if I heat it strongly, it gives calcium oxide. Now, add the calcium oxide to water, it will form calcium hydroxide, which is the slaked lime. And you need to include, of course, the equation. Here he's saying write equations to show the thermal decompositions of each of these nitrates. So, sodium nitrate, nitrates of group 1, when they are heated, they give what? They give sodium nitrite plus oxygen, and this is the balance. Magnesium nitrate is a nitrate of group 2. When we break it up with heat, it gives the oxide plus nitrogen dioxide plus oxygen, and we balance the equation. Magnesium carbonate decomposes readily when heated, but sodium carbonate does not. Explain by including reference to the charge and size of the cation. So remember that the magnesium carbonate is a big ion atomic group, and the magnesium is a small ion, so the magnesium has higher charge than sodium. So first of all, why is Na plus not able to break? Because the charge on the magnesium is higher. It has a smaller ion, so more polarizing power than the Na plus. Now, polarizing power means that the CO bond in the carbonate breaks more easily, and magnesium carbonate would decompose more easily. You have to know how to explain all of this. Compound X is an anhydrous white solid which decomposes on heating to form a white solid residue, a colorless gas, and a colorless vapor which condenses to a colorless liquid. Okay, let's see this. So he's saying I want to start with one of these. It should be a white solid at the beginning. Well, all of them are white solids. Decomposes on heating to form a white solid, colorless gas, and colorless vapor. So if I heat sodium carbonate, first of all, you should know sodium carbonate is the group 1 carbonate, and they do not decompose on heat. So sodium carbonate is not easily broken down. So this is not something that can be an answer. Okay, sodium hydrogen carbonate. Sodium hydrogen carbonate, if I heat it, it will give me sodium carbonate, carbon dioxide, and water vapor, which is something that could condense and form water. So this is the answer that he's looking for. When I heat it, it gives what? It gives a solid, which is sodium carbonate, a colorless gas, which is carbon dioxide, and a colorless vapor, which condenses to a colorless liquid, so that could be the water. What about sodium nitrate? Well, sodium nitrate, when I heat it, it gives only sodium nitrite plus oxygen, so it doesn't give any of what he's talking about, and so is the case with sodium sulfate. 2 white powders A and B, known to be group 2 carbonates, are investigated. The presence of the carbonate ion is usually confirmed using a simple test. Describe this test. Of course, presence of carbonate ion, we said we add dilute HCl, and what happens is I should see bubbles of gas that turn lime water milk. Then he says, using barium carbonate as an example, write the equation for each of the stages of the carbonate test. Well, what did we do first? We added hydrochloric acid, so this is what should happen. And then we pass the carbon dioxide through lime water to form the calcium carbonate, which causes the lime water to be milky. So these are the equations that you should be able to write. When a flame test is carried out on two powders, A gives no color, B gives a yellow-red flame. Describe, first of all, how a flame test is carried out. Do you remember how we carry out a flame test? We said clean a platinum wire by dipping it into concentrated hydrochloric acid. Then insert the platinum wire into the solution to be tested, and then insert the solution into the non-luminous part of the flame and determine the color obtained. So when we do this flame test, he says A gives no color. So what do you think is A? We said the one that gives no color is magnesium. Remember, he's talking about group 2. So this is magnesium that gives no color. B gives a yellow-red flame. Which one gives a yellow-red flame? Calcium. Okay? So just why compound A produces no flame? We said, why is it that magnesium does not produce a flame? This is because the emitted radiation is not in the visible region of the spectrum. When group 2 metal carbonates are heated strongly, they decompose, forming metal oxide and carbon dioxide. Explain why the thermal stability of the metal carbonates increases as the group goes down. We said when we're talking about carbonates and as we go down, the thermal stability increases. That means they do not break up easily. This is because going down the group, the metal ion radius increases. So charge density decreases, polarizing power of the cation decreases, polarization of the carbonate of the CO bond in the carbonate ion decreases, and the metal carbonate is more thermally stable, less easy to break up by heat. Okay, you should be able to explain this. And remember, this happens for all the large atomic groups. So this is the same explanation for carbonates, sulfates, and nitrates. The only one that go in the opposite direction is the hydroxide ion. A flame test was carried out on a mixture of magnesium chloride and potassium chloride. So what color should we see? Remember, the magnesium doesn't give a color. So the color that I see will be the color of the potassium, which is light. The equation for the reaction of lithium with excess water is this. So which of these? We're talking about lithium with water. Lithium reacts with cold water, so it gives the hydroxide plus hydrogen, and this would be the correct balancing of the equation. Solid sodium is reacted with chlorine gas, and the product of this reaction is added to water. So what we have is sodium reacting with chlorine. This, of course, would give what? It will give sodium chloride. Now he's adding this product to water. So it's basically sodium chloride is salt, the table salt that we use. When we dissolve it in water, what do we get? We get a colorless solution. The next question says the solids barium hydroxide and barium sulfate are similar in what? Well, let's see. Barium hydroxide and barium sulfate, they are similar in what? Well, they are only similar in their colors. Remember that both of them will have white color or a white solid. The pH is not similar. Why? Because barium hydroxide is more likely to ionize in water and form an alkaline solution. Barium sulfate would not form an alkaline solution. Their reactions with hydrochloric acid, again, it's the barium hydroxide that will react with an acid to form salt plus water. Their solubility, well, the solubility of barium sulfate is much less than barium hydroxide, so they are only similar in their color. The solids magnesium carbonate and magnesium nitrate are identical in what? And please remember the word identical. Well, When we have magnesium carbonate, when we break it up, it gives magnesium oxide and carbon dioxide. The magnesium nitrate, when we heat it and break it up, it will give magnesium oxide plus nitrogen dioxide plus oxygen. So he's saying they are identical in what? The gas released on heating the solids? No. Both solids will give different gases. One will give carbon dioxide and the other will give oxygen. Their reaction with hydrochloric acid, well, with hydrochloric acid, the carbonates will react and form salts plus carbon dioxide plus water. So this would not be the same as the magnesium nitrate. The solid product of their thermal decomposition, yes, they both form magnesium oxide solid on heating. So that is what they are similar or identical in. Their solubilities, no, they're not exactly identical. Both of them would not dissolve very easily, but it's not identical. Which of the following is the correct equation for the decomposition of the nitrate? Okay, which nitrates are we talking about? Well, lithium nitrate, it will break up to form oxide plus nitrogen dioxide plus oxygen. The sodium nitrate, no, we said the sodium nitrate, when it breaks up, it forms the nitrite plus oxygen, so that equation in B is wrong. Magnesium nitrate and barium nitrate, these are wrong. When they break up by heat, they give the oxide plus NO2 plus oxygen. So A is the one that's correct. Remember, as we said, group 1, all nitrates of group 1 will give the nitrite plus oxygen except lithium, which acts as if it's in group 2. When steam is passed over heated magnesium, well, magnesium with steam, what do we get? We get the oxide plus hydrogen, and that is the correct balancing of the equation. Barium reacts with water to form a clear, colorless solution. Give the name or formula of the barium compound. When barium reacts with water, it reacts with cold water. It forms barium hydroxide. Remember we said the reactive metals in group 1 and at the bottom of group 2 will react with cold water. When they react with cold water, they give the hydroxide. The others which are at the top of group 2, like magnesium, when they react with steam, they give the oxide. State another observation that would be made when barium reacts with water. Of course, it gives, when barium reacts with water, it will give hydrogen gas. So the other observation would be bubbles of gas. Which of the following is the equation for the reaction of calcium with excess water? Well, calcium reacts with what? It reacts with cold water, and we said when it reacts with cold water, it forms the hydroxide plus hydrogen. And how do we write hydroxide? That equation in C is completely wrong because the formula of calcium hydroxide is wrong. So it is A that is correct. Thermal stability of group 2 carbonates increases down the group because of what? Again, because the cation is less able to polarize the anion. Remember that the cation has to be small, high positive charge in order to be able to polarize the anion. As we go down the group, the cation becomes larger, less charge density, less ability to polarize the anion. Okay, a white solid produces oxygen when it is heated, but no other gases. So we said which one will give oxygen but not any other gas? Lithium nitrate, we just said. When we heat it, it gives the nitrogen dioxide gas and oxygen gas just as if it's in group 2. But the group 1, potassium nitrate, is the one that gives only oxygen gas. The strontium is in group 2. It will give nitrogen dioxide and oxygen. So my answer that gives only oxygen is actually the potassium nitrate. I hope you're able to think about these questions. You can stop the video at any time and check to see if you can get the correct answer or not. Two white powders are known to be barium carbonate and magnesium carbonate. How can you distinguish between the two powders? Include the equation for the action of heat on one of these carbonates. Again, you should realize that magnesium carbonate, because I have small magnesium ion, high charge density, and large carbonate ion, this will decompose more easily. It gives bubbles of carbon dioxide gas, while barium carbonate is thermally stable or much more difficult to break down by heat. So just another test. other than heating or use of acid, which could be used to distinguish between magnesium carbonate and barium carbonate? Well, I would use flame test. With magnesium, there is no color. With barium, it is an apple green flame. Thank you for listening. I hope that this is helpful to you, and we'll do the next chapter next time.